Hello guys, my name is Stan and I'm one of the co-founder of Quiver, and I originally created Quiver, which is today, so it's an open source project and we currently have 28,000 stars. The goal of Quiver is to be an open source chatbot second brain. And so what you can do technically is you create what we call brains, and in which you can upload files, you can chat with your APIs, you can create custom brains. So for example, here I have GPT-4, or I have, I don't know, RFI, RFPs, a brain which knows what Quiver is, and you can ask a bunch of questions using LLMs. And this is what I'd like to talk to you about today. So if you want anything, if you have any information, you can go to Quiver HQ/Quiver, and you can look at the code and you can run it locally if you want and you're interested in running it locally to try it. So let me start with explaining the infrastructure of Quiver. And so what you can see with Quiver is we are using Supabase. So let me draw something for you. We are using Supabase as an alternative to Firebase, which means that, you know, we get the authentication, we get the database, we use it for storage, we use it for edge functions like Lambda functions and all of that. And one of the reasons why we do that is that you can run everything locally. So first thing first, use a Supabase to run things locally. The second part is we use Ollama. And Ollama, or OpenAI for the LLM part, /OpenAI, allows us to use pretty much any LLM we want with what we call light LLM, another open source project. So light LLM, through light LLM, we use Ollama OpenAI. You can switch any models you want. You can run them locally. And the last thing is for the backend, what we do is we use FastAPI. And inside FastAPI, so this is a Python library, we use LangChain. And I know that many of you don't like LangChain, but one thing that is good with LangChain, it allows you to build things very quickly. And they provide you with a lot of value from the different tools. And so yeah, that's the thing. Supabase, light LLM, FastAPI with LangChain. And the last thing is usually in what we call a chatbot, you tend to have either in our case, it's a RAG, so we have files that can be uploaded and read, and so we use OCR, and in order to do that, we use a library called unstructured. So now that you have all of that, you try to see that we use many things for different use cases. And if we look at Quiver, for example, and we just go to the pip file, so this declares dependencies. We have a bunch of dependencies because we create a chatbot that allows you to chat with your documents, with APIs. We have OCR for uploading files. That means that our Docker image is getting very, very, very big. And one of the things with chatbots is because LangChain and LLMs are really written with Python, you have to use Python in most of cases. And Python is really bad at managing dependencies. And so we used to be able to manage down the size of the Docker image to around 400 to 500 megabytes. But now, the more features we need, the more it gets big. So, for example, we added unstructured, and unstructured came with a lot of packages like Tesseract and all of that for OCR, which made the Python image 10 times bigger, the Docker image, sorry. And in that, now we get 5 gigabytes Docker image for Quiver. And that's good and that's bad. Okay, so we managed to package everything. So how does Quiver work currently? And this is one of the things that you really need to be careful about.
So a few months back, at the beginning of Quiver, if we look at the uptime of Quiver, we had an issue last week. If we look back in the time here, you can see like most of the days it was not very good. And that happened because we had one package, like one image for everything. So like the API was doing everything, like chatting, uploading files, answering questions from the database, and that meant that if something was taking too long, then we had an issue. So let me show you why chatbots are going to be very hard to host. Because when you have a chatbot, so you have a chatbot, okay? And so what the chatbot does is when the user sends a request, so let's say we have the user here, and the user sends a request to your chatbot app. It's going to take, so it's going to, like you have chat number 1. Let's say you have, we have another user that does chat number 2. And you have another one, chat number 3. What it does is it used to, and then last one is not chat number 3, but it's just a simple API request. So what tends to happen is if you have a monolith application, and which is, because this is a fairly new way of building things, chatbots are not very popular. You have everything the same here. So that is going to be one thing, and you see where I want to go. It's everything is going to be connected, and the same backend will respond for all of that. The difference is if we go to Longsmith, for example, and we look at a question. So Longsmith is a tool that allows you to see the input and output of the questions that have been asked on your project, which uses LongChain. And so if we look at the latency, we can see that 50% of the time, a query takes 3.5 seconds. And this is not, it's the first time to token. So that means that here, it took 4.22 seconds to answer the question, and the first token took 3.78 milliseconds. So we are currently using streaming. That means that once we have the first token, we send the answer, but it takes 4.22 seconds in order to answer the question, and 50% of them, 3.5. And the thing about that is, when you used to have, just simple API requests that did, a call to the database, what you could do is simply pump up the size of the database, and you could say, okay, let me add 4 gigabytes of RAM, 2 CPUs, let's increase that, let's, add indexes. The issue here is that on average, what we have seen is it takes 12 seconds. And this one, it's like 4.5 seconds in the worst case scenario. So here, when you have 3 users that, talk to your backend, and all of them take 12 seconds, that means that you have connections that are taken, and it can be sometimes quite, it's not CPU intensive, but because we use fast API, we have what we call workers, and workers are RAM intensive. And so we had to scale the number of workers, so we had to scale the RAM in order to accommodate all of these users. And if you have all of your connections that are taken for 12 seconds connections, you can't answer the basics of this one, which takes only half a second. So one of the things that we did, and if we look at the code of Quiver, is if you go to .aws, what we did is we decided to separate a few components. At one time, we decided to separate in many ones, but like chat, upload, and all of that. But then we realized that
what was really taking a lot of time was the upload of files and the chat. So what we did is we made something asynchronous, that we call the worker, that uses Celery. And this one is big because it does OCR. And it's when a user uploads a file to Quiver, it works on the worker. But now we have huge, how do you call that, containers, so like 5 gigabytes, and because we weren't able to separate it into different code bases, we still have a lot of RAM and CPUs for a container that does just chat and API requests. And that's the reason why we do that, is because we have, it takes a bit of time to answer the question. It's under-optimized, I know, but we had to do that because the app takes a very long time to answer. The first thing is because Chatbots needs a lot of dependencies, if it's not just a simple one. And so we have more than a minute to boot. So that's very long, it doesn't scale very well. And that's like kind of the overhaul of Quiver, like what we did and what it is. Let me showcase you now the infrastructure behind. So we separated it into, let me give you one last image. So so what we did here is when the user comes here, if it's just for chat or API, it goes through a container. But if it's for uploading a file, and uploading a file can take a few seconds or sometimes minutes, it goes to another container. What we really need to do is then, if we want to make it better, is we want to separate the chat from the API, which are CPU-bound calls. But that takes a bit of time because everything is intricated into our code currently. So that is going to be a really hard thing to do in the future. But that's one of my advice, is at the beginning, try to separate the chat, which is bound to the LLM. And LLM take a lot of time to answer, rather than the API calls, which are, CPU bound, because they are connected to a database, or it's your index that is not very good. So what we did is, when you build a chatbot, simply we used what we called ECS, Elastic Container Service, and we are in the Parisian region, and we decided to go with a managed service because it allows you to go very quickly in production. We tried Kubernetes, but it's almost the same thing. But here, if we look at the containers, the backend, we have currently 5 running backend, and that's they are doing very good, and it's not optimized. But if we look at, I think, more like 1 week, we have sometimes like it's underutilized, but because the request takes so long to answer, even if it's not CPU bound, the RAM is still high, and sometimes we have restarts because we use bot instances. Because we are taking 12 seconds, we need to have the workers, the UVCon workers, we need a lot of RAM, but it's not CPU intensive. But so that's one of the things, is if you can make your chat instance very small, and if you can use, for example, lambdas to answer your your chat, that's going to be amazing, because here we pay way too much and we use way too many. So for example, here it's like 2 vCPUs, 8 gigabytes of RAM, for 2 reasons. Our Docker image is huge. We wanted to be able to scale down and up very quickly. But the second thing is because we use fast API and workers, and we are very CPU RAM bound, we need big computers. So yeah, try to put the chat in your, like, alone. You don't want the chat in your code. And also that's one of the reasons why here is because we had like a lot of people asking questions on Quiver, and we weren't able to answer all of them at the same time. And what happened is, because it takes 12 seconds to answer a question, the issue at the end was when it was answering too many questions, you couldn't do anything else on Quiver. Like, you couldn't go to this page, would not load, because, you know, it's an API call, but chats were going. And yeah, for example, you know, loading something. So one of the advice, and let me draw a screen, is if you don't want your applications to kill your AWS infrastructure, GCP, Azure, or locally, is the first advice is the first thing is chat. Let me zoom in a bit. The chat in its own container, and just that. The second part is everything that, if you do a RAG, for example, when you start to require dependencies, separate. Like, it's, I would love to say like microservice, especially with Python, because it needs a lot of, you know, dependencies. But yeah, really try to separate all of your components, because you'll tend to add more and more features to your product, because chatbots can do many things, and your image is going to be huge. So for example, if we go to Docker, you can see that, you know, up. You can see here, let's see, 3. So yeah, on ARM is smaller, but 3.3 gigabytes. And if we look, I don't know, the oldest one used to be only 333 megabytes. So yeah, that's a huge difference, because we kept adding features and features, and we needed to install more and more packages, and also more and more things into the default container. So yeah, so first thing, put the chat in its own container, in its own instance, on a Lambda, whatever you want. Try to do microservices. I think that for chatbots, you don't want to put the code of your chatbot into your monolithic app, because if you have too many users at one time, nothing will respond. And the third thing is monitor your costs. Really. Monitor your costs. One of the reasons is because it already costs a lot of money to host LLMs. So try to monitor your costs. Make sure that, you know, it's good. One of the things that happened with Quiver at one time is we, you know, because we didn't put the chat in its own container, and we didn't do microservices. Everything was in the same place, and we had way too many instances, and it cost too much money for the amount of users that we had. And then you also have to pay for, if you use, for example, OpenAI, you have to pay for OpenAI. So really look into your cost. And one advice, if I can give you, is use Sentry to identify the long running queries. And one of the things that I really like is that, and if you look at, for example, some very bad requests, but if you look at the P95, you can see that, like, the upload and the chat are the one, and the streaming, you know, it takes, some of them can take a very long time to answer. So try to upload, let's also chat. So yeah, look at Sentry, try to optimize, put the chat and the upload on one side. All of the things that are CPU bound, you know, you can fix it later on. But yeah, this is all of the learnings that I got from Quiver, and your cloud bills will be way, better if you put the chat somewhere else and you make it as small as possible and as scalable as possible. And that's something I wish I did on Quiver from day one. So now we need to, change the code, refactor, do things, and it doesn't add a lot of value. So, if you take one day, if you take a week to do that, you need the difference in pricing from AWS or your cloud instance. You make back the money in like 6 months. So you don't really need to do it today, but you have to do it at one time. And so for now, it's too expensive to do it based on our usage, but also it could improve the stability of the application and all of that. So yeah, you really separate everything from day one. And if you want to look at how we did it and all of the mistakes that we did, you can simply look into Quiver's code. Everything is open source. We deploy everything locally, and yeah, have fun, guys.